The AI for Good Global Summit, convened by ITU, recognizes the joint responsibility of governments, the private sector, United Nations agencies, academia, and others to ensure AI reaches its full potential while preventing and mitigating harms.
And it's a moment that calls for action. And today I'm calling on each of you to use this summit to help the world to better understand what kinds of regulations, what kinds of guardrails we need to put in place right now. So together, let's make it innovative, let's make it safe, and let's make it responsible for all. Thank you very much.
Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Hello, and welcome all to this session on the launch of 2024 GeoAI ITU GeoAI Challenge. My name is Andrea Manara from the ITU, the International Telecommunication Union, and I'm really pleased to introduce the launch of this competition now in its third edition. Since 2023, for the second edition, we partnered with the Africa platform, and we had last year 5 problem statements and more than 1,500 participants from 60 countries. I want also to remind you that in parallel to the GeoAI competitions, we also run the GeoAI Discovery Channel, where we discuss GeoAI applications, including climate actions, spatial digital twins, energy ecology, agriculture, water and food systems, health, and more recently, we are focusing the series on geospatial large language model and the GeoAI and education under the leadership of the curator of the series, Maria Brovelli. If you're interested in this series and you missed some episodes, don't worry. You can watch the recordings of those events on YouTube or on the neural network to which you are connected right now. I will now make a quick introduction to the challenge, and then I will give the floor to the hosts of the problem statements. Let me share my screen so that I can share. Yeah, you should be seeing my PowerPoint presentation.
We do.
You do, and then now I will just, okay. So this is the agenda. I will discuss the goals, objectives, and the outlook of the challenge, and then we will have the free problem that we will launch this afternoon. The challenge for agricultural plastic cover mapping with satellite imagery from FAO, the ground level NO2 estimation competition that is curated by Politecnico di Milano, Department of Civil and Environmental Engineering and University of Padua, and then the GeoAI challenge for clandestine runaways detection in the Peruvian Amazonian basin with open source satellite images, which is curated by the United Nations Office on Drugs and Crime. And then we will have an outlook from Maria Brovelli, Politecnico di Milano. So we organize the competition in such a way to give the possibility to solve real-world geospatial problems by applying artificial intelligence, machine learning to advance the United Nations Sustainable Development Goals. Which are the benefits? So participants have a platform in which they can gain hands-on experience related to GeoAI and have the opportunity to define and work on technologies related to GeoAI. Also, what is very important is the possibility to network, meet people, experts and peers, and then getting global recognition in forms of prizes, appreciation, and there is also the possibility of publication of the work in a journal. And then, of course, employment and internship opportunities that can always arise. The benefits for partners or the institution which submit a problem is to get visibility through the year, find global talent, and also innovative solutions to their GeoAI use case. ITU for each problem offer $1,000 francs. I have a mistake here, I'm sorry. The 1,000 in total will be 500 for the winner, 300 for the second place, and 200 for the third place. And also, it's important to note that not every problem may necessarily have a winner if the quality is not good enough. We also have certificates. We also offer a compute platform. We offer free GPU access to participants who don't have enough computational resources in their institution. About the possibility of publication of the work, we are having special issues on geospatial AI, and so you can submit your work until end of August. And then I will introduce afterwards our leading guest editor, that is Maria. Only to have some numbers about last year's competition. You see that we had 5 problems which were submitted by different organizations. And overall, we have more than 1,500 participants from more than 60 countries. Only to put some faces behind a competition. In this case was the cropland mapping, and we had one organization, the United Nations Organization on Drug and Crime, who allocated also additional 3,000 Swiss francs. So we were able to have more people getting an award. So we now finished the curation phase, and we are starting the competition phase. And then afterwards, in November, we will start the evaluation phase, and the winners will be awarded on a webinar. I mentioned that we have 3 problems which are ready to launch, but we have 2 more which are still in the curation phase. So we hope to launch other problems very soon. So with this, I invite all of you to join for this year's competition. I will stop the sharing of my screen, and I will ask Maria to join me on stage. Hello, Maria.
Hello, good afternoon, good morning, good evening to everyone. And thank you, Andrea, for your brilliant presentation.
Thank you very much, Maria. Always very kind. Let me now introduce just briefly Maria, but I'm sure that you all know her. So she's professor of GIS at Politecnico di Milano, a member of School of Doctoral Studies in Data Science in Roma La Sapienza, Amongst her many activities, she's the Vice President of the Commission of Geospatial Information of the ISPRS, Chair of the UN Global Geospatial Information Management Academic Network, and co-chair of the United Nations GIS initiative. So now I will give the floor to Maria, and she will introduce the speakers, and we'll see you later. Thank you very much, Maria. The floor is yours.
Thank you, Andrea. Yes, and I believe that it's time of knowing the challenges and the people behind these challenges who will also mentor you with respect to the challenges. Okay, so let's go to the first challenge we want to present today. That is the challenge proposed by FAO, agriculture plastic cover mapping using remote sensing. And so I'm calling Peng Xu. Peng Xu, welcome, good afternoon. And just to introduce you very quickly, Peng Xu Hao received the PhD degree in GIS and remote sensing in 2017 from the Institute of Remote Sensing and Digital Earth, Chinese Academy of Science in Beijing, China. He is currently a consultant at the FAO, United Nations. His research focuses on agriculture remote sensing applications, including agricultural land cover mapping and crop growth monitoring. In addition to that, he's also responsible for managing the remote sensing tab on hand-in-hand geospatial platform. Thank you, Peng Xu, and the floor is yours now for presenting this exciting first challenge.
Okay, thank you, Andrea, and thanks, Maria, for your introduction. And now I will share my screen to present the challenge. I think you can see my screen.
Yes, we can see.
Okay.
You have to go to presentation mode.
Okay.
Wonderful.
I will begin. Hello, everyone. My name is Pengyu Hao from FAO. And this year, the topic of our proposal for the GeoAI challenge is to using satellite images to identify the agricultural plastic covers. This challenge is led by the UN Open GIS initiatives and also the GeoAI Working Group 5. Here is the outline of the talk. The first part will be the background of this challenge, and then the objectives, and followed by the plan details, and finally the take-home messages. First is about the background of the agricultural plastic cover mappings. Basically, because we are now working on using the AI technologies for agricultural applications, so there have been a series of applications of AI from the remote sensing community. The most commonly used technologies use AI to identify objects or to identify land cover classifications, just like in our last 2 years GeoAI challenge on cropland mapping. So in this year, we will move on to a new topic, which is to identify the agricultural plastic cover, which is more in detail information than the cropland. Basically, all the crops are growing on the ground, but in some very cold regions or drought regions, if there is no facility for the agriculture, the crops will be under stress, and no yield will be acquired at the end of the growing season. So in these regions, a new technology used to improve the crop yield is to use some facilities such as a greenhouse or the plastic moist fields. And all these technologies will change the environmental conditions for the plants, and in this case, the environment in these facilities will be suitable for the crops to grow, so that we can have them. It can improve the crop yield, and also improve the conditions for the crop growth. But together with the improving of the crop yield, there will be some limitations for caused by the using of all these plastic covers. That is, after the harvest of all these crops, most of these plastic cover will be stayed in the field as a waste. So it will cause very serious environmental pollutions. So there is a very urgent need to identify where these plastic cover distributed globally, or so this is the background of this challenge. And here is the objective of the challenge. The major objective is to use machine learning methodologies and algorithms to identify the agricultural plastic covers. Here, there are some drawback of or difficulties of using satellite images to identify all these agricultural plastic covers. That is, there is a large uncertainty of the spatial distribution of these plastic covers. For example, some plastic covers temporarily occurred. For example, the plastic merged fields. For all these plastic covers, it is only visible in the period of the plastic cover time phases. And after the crops growing up, it is quite difficult for us to identify all these plastic covers from the satellite images. And there are also some other types of the plastic cover, which is a greenhouse. It is more looks like the permanent plastic covers. So the algorithm is we have divided the year of the year 2023 as 24 time phases, and we will ask all the participants to identify the plastic covers of all these 24 time phases, which will be the basement for both the temporal plastic cover and the permanent plastic covers. So the most challenge is to test the extendability of the proposed algorithm for all the time phases and the different test regions. And the output of this challenge will contribute to the UN and GeoAI communities. So here is the overall plan of the challenge. We have put some background information on the web page of this challenge. So the website is now ready, and all the dataset is now also ready for download. And here is the time range. Firstly, we have this call for submission today on July 9th this year, and then the deadline of the submission will be on the November 11th of this year. And after we have all the submissions, we will have some first round evaluation and notify some of the selected teams on the late November. And after all the evaluations, we will have the presentation defense to finally have a score for all the submissions in the early December. And finally, we will have the award ceremony in middle December. This is now our plan. In this year, for this challenge, we have 3 test regions. They are located in different continents. The first one is located in the south of Spain. The second one is located in the Kenya, and the third one is located in the South Asia as Vietnam. All these 3 test regions have large area of the agricultural plastic covers, like greenhouse or plastic mulched fields. And for each test region, we have prepared the 15-day composited Sentinel-2 images with 10-meter spatial resolutions, and all this data are now available in the Earth Engine site. The data is prepared in the year 2023, so there will be 24 time phases in total. And we have also provided the training samples for the participants. For each test region, we have prepared about 500 training samples for the users to train their classifiers or classification models. But it is notable that all our training samples are collected using the images of April or May of the year 2023. So the participants can use our training samples to export the multiple spatial informations from the satellite images and use all these feature informations to train their classifiers, and then using their trained classifier to identify the agricultural plastic cover of all the 24 time phases and in all the 3 test regions. We hope that all the algorithms could be implemented in the Code Lab, which is provided by Google for free. I think maybe ITU could also provide some GPUs or computing resources for the participants. And here is a checklist for the submission. First is about the agricultural plastic cover distribution map. As we have 24 time phases and 3 test regions, so we will ask the participants to provide all the 72 images for these 3 test regions. And together with the map, the participants should also provide their technical report with the accuracy assessment report. And finally is the training dataset. Although we have provided some training dataset for the participants, we encourage the participants to add in some training samples and use both the training samples from provided by us and collected by themselves. But we hope that the training sample dataset could be as small as possible. And finally is the script for the data processing in the core lab, because we are the open UN initiatives. So with all our scripts, our data will be open. So we ask the participants to provide their scripts. And after we have all the submissions, we will evaluate with accuracy assessment, evaluating the size of the training samples, the performance of the algorithms, and finally we will evaluate the novelty of the submitted technical report. And finally, we will select some teams in our presentation defense webinar to have a final rank of all the selected participants. So here is the take-home messages. We will provide test regions, satellite images, and also training samples. The participants will have their training samples, their maps, and scripts. And to remember that the submission deadline is November 11th of this year. And that's all for my talk. Back to you, Malia.
Thank you, Peng Shu. Very clear. I want just to underline again that we want everything to be open and applicable by everyone. And therefore, if you are using different data sets, training data, and so on, please provide also this data in such a way that everyone can on is Peng Shu. Thank you, Peng Shu. With respect to the ITU, ITU is offering, in any case, I'm speaking on behalf of Andrea, but ITU is offering this facility for computation in case people don't have enough strong machine, as it was presented before by Andrea. Okay, thank you. Let's see after if there will be some questions, but everything was super clear. Thank you, Penchu. And now we are going to the second challenge. Second challenge is about ground level NO2 estimation, and it will be presented by Francesco Pirotti. Francesco Pirotti from the University of Padua. And this project is within the project GeoAI. But what we can say about Francesco. Francesco, so after a 1-year study and research period as exchange student at UC Berkeley with a grant from an Italian foundation, he obtained his PhD at the University of Padua with research that focused on satellite image analysis. With his group, Francesco is involved in several EU and national research projects with various roles. He co-authored more than 200 papers in scientific journals. He is affiliated and proactive in the scientific board of CIRGEO, the Interdepartmental Research Center of Geomatics at the University of Padua, and in other national and international scientific societies. Then in 2020, Francesco co-founded and now is the co-director of a 1-year master program in geostatistics for One Health. He teaches GIS and remote sensing in several courses in environmental science programs, and he enjoys to research on new methods for surveying, representing, and making sense of spatial data through analysis with novel tools. So welcome, Francesco, and the floor is yours for convincing people in participating to our challenge.
Thank you, Maria. Good morning, good afternoon, everybody. I hope you can hear me well. If there's any problems with the connection, please just say so, but it should be okay.
No, it's okay, it's okay. And we see your screen, yeah?
Okay, so
and now
thank you
in
again.
presentation mode.
Great. So I'm here to present this particular challenge that's been co-curated with Politecnico of Milan, and as Maria said, I am from University of Padua. I am part of the Department of Land and Environment and Agroforestry, and I'm also part of the Interdepartmental Research Center of Geomatics. And what I'm going to talk about briefly is the method, let's say the research problem of understanding more about pollution at ground level, and how can remote sensing and artificial intelligence help us to understand more about this phenomenon. This actually started with a national project that Maria mentioned, and where we are also collaborating with Politecnico of Milan and Polytechnic of Marche. It's called GeoAI, so it's very, let's say, in the same direction and topic as the challenge. And the title is Geointelligence for Improved Air Quality Monitoring and Analysis. Now, you will see that my team, we're quite multidisciplinary, and in particular in this part related to atmospheric pollution, remote sensing, and machine learning and artificial intelligence. Two people are particularly involved. One is Luca Mamic. He's actually now traveling. I don't know if he's maybe listening to us online, but he prepared the data set, so he's going to be interacting also with participants. And also another person is Denise Führer. She's actually in the project, and she's more working on the health part. Now, The problem is quite probably everybody, all of us have been in places and in times when there's very high pollution. This has become a problem. It has been a problem for quite some time since let's say, the Industrial Revolution, with our devices, cars, heating, and industries, which are actually maybe less polluting, but they are more numerous. And then it also depends on the quality of the pollution. So actually, we are not obviously in a natural environment anymore. We are breathing, and our, let's say, the people, our bodies are interacting with an environment which is not what it was before the Industrial Revolution. In the terms of air quality, this is quite very well known by the World Health Organization, which, depending on where you are, you could be there is an impact on your health. This is undoubtable, and we know where it comes from. Of course, it's something that the policies are trying to mitigate. We all know fossil fuels, natural gas, etc. So there's different type of impacts, different type of marginal, let's say, pollutions, and actually activities which are more or less impacting. And there's policies which are trying to take care of it. And our role, I think, as scientists and using remote sensing and using artificial intelligence, is trying to support decisions with data evidence. As Maria said, this is quite something I feel strongly about. That's also started as a program, a master program with the unit of biostatistics here at the University of Padua. They take care of the health issues, and our team takes care more of the data processing, the remote sensing data and spatial data processing, also with artificial intelligence. Now, as you can see, there's two very particular spots, and yes, you guessed it, this is Milano and Padova. They are quite, of course, this is quite, a catchy image. This is one of a period of time which you could say the worst case scenario, where the pollution is actually sticking to the area due to also meteorological reasons. So we have this problem. It's quite felt in the northern part of Italy, because it's like, let's say, a closed region, and there's not much air, basically there's not much wind. So the pollution tends to stay, also because there's a lot of humidity. So this has an impact on health, and that's what drove the research interest into understanding more about air quality. I bring here some SDGs. This, of course, is correlated to climate effects, because climate does have an effect on the air quality, and of course on life on land, and we just mentioned it, health and well-being. Now, this video shows a little bit, because what we are going to do in this challenge is not just take into consideration the spatial part, but also the time series. And as you can see from this video, Earth observation, remote sensing, provides information, but is not always complete. There are gaps in time and in space. So that's something that artificial intelligence can address and can actually fill with science-based and rigorous methods, so we can interpolate basically the data to have a more complete mapping in time and space of the thing we're interested in, which is, in this case specifically, is NO2. One, as I said, again, space and time. What you see here on the right is a diagram which shows, you could say, a transect in space, and also shows a time series, because what we are actually looking at, the concentration of this pollutant changes with time. So we can also provide information not only of where it's more concentrated, so maybe a bit more dangerous, but also when its let's say higher levels or lower levels. And the interesting thing in this work that we did is that you see some gaps, probably, this is an hypothesis, we did not test it, is correlated to both the COVID lockdowns, that's quite well known, but also some let's say holiday seasons, which changed the use of the emissions levels. It could also be probably due to climate reasons. Now, the interesting thing, what we are actually looking for is actually to see how well we can correlate what is on the ground, because satellite basically shows us what is on the atmosphere, but the ground situation might be different. So artificial intelligence can help support, because as we see from this plot, this is a very generic plot. We see a correlation. It's just very simple correlation, but we could actually provide a better model so that we can actually predict what we see on the ground using satellite data and satellite products. So not only the atmospheric products from satellites, but also other products that can help, that are correlated to the ground level NO2 and can help us to predict that. Let's go to the challenge. So when you download the challenge package, what you will see is a set of data. So these are the variables that you can use to predict the dependent variable, which in this case you will see as GT, ground truth, NO2. This was collected from the stations from the environmental agency of the various regions. The area is the regions of Lombardy and the Veneto region, so the area that we saw before in the images. And so the northern part of Italy, that's the study area. And you get this information. So you get a file with data description where you see the units and also the sources of data. The sources are all available in Google Earth Engine, but are also available from the original sources, like the CHIRPS data set, the temperature information, etc. You have a training data set, so a matrix basically with about 86,000 observations. And as you can see here, these are your potential explanatory variables. You are free to find other variables. That's very important. You can go and look for sources of data, preferably, as Maria mentioned, open data that can support and improve your prediction of your dependent variable, which is the ground truth NO2. So our target is to get as best as possible the ground truth NO2 concentration by training our model. So this is the trained CSV that you find in the package. You find a test CSV without, of course, you will not find the ground truth information because that's the objective. That's what you have to provide in the challenge. So once you train your model, you will use this to get the ground truth for each line. And so this is the test data set that you have to use for prediction, and you find a sample submission. So at the end, what you have to provide is the ground truth NO2. And you see all the two other columns are, the first column is the date. So when is the concentration predicted for, and where, which is the ID of the ground station. Of course, we have the true values, so we can provide you feedback, give you feedback about how accurate your prediction was. A short summary. So the competition, as the presenter before me mentioned, closes the 11th of November. There's some prizes, which is always something that motivates people. And again, I would like to underline what I said before. You have some predictors already available for you. Those predictors are related to climate. So there's temperature, there's precipitation, There is the NO2 information from the Sentinel-5 precursor that's available from the Copernicus program. And but you are more than welcome to find other data sources, ideally from remote sensing, and you're strongly suggested that these are open, not only free, that they're open data sources so that your method can be fully replicable. And even your method, if you want to share it on GitHub or other ways, make sure that it's as replicable and accessible as possible, as you can see here. So this is all from my side. I give the word back to Maria.
Thank you, Francesco. You were very clear, or at least I know very well the statement, and so at least for me it was very clear. I want only to add that also Politecnico di Milano is contributing to this challenge, and specifically Rodrigo Cedeno helped in preparing the data, just because you forgot to mention it. Okay,
Rodrigo
thank
was
you.
fundamental.
Thank you. And let's go to the next one, which is also the last one. So we have the last challenge, which is related to clandestine runways detection in the Peruvian Amazonian basin with open source satellite data. And we have as presenters Lorenzo Vita and Jorge Caballero. Lorenzo Vita, an Italian national born, has built a career in the field of geographic information systems and environmental research. Currently serving as a geospatial information officer for the illicit crop monitoring program at the Research and Trend Analysis branch of the United Nations Office of Drugs and Crime in Vienna. Lorenzo has been actively involved in designing and implementing technical assistance programs for the development of national illicit crop monitoring systems. Lorenzo holds a professional master's degree in geomatics and natural resources evaluation and a Master of Science in tropical and subtropical agricultural science. But I want also to introduce the second speaker, so Jorge Caballero. Jorge is a Peruvian biologist with expertise in remote sensing and a master's degree in sustainability. His research focuses on using remote sensing and geographic information systems to assess the ecological impacts of environmental crimes in the Peruvian Amazon. Currently, Jorge works as a remote sensing specialist for the illicit crop monitoring program at the United Nations Office on Drugs and Crime in Peru. He monitors illicit crops and other illegal activities that cause deforestation, analyzing medium and high-resolution satellite imagery together with drone data. He employs spatial modeling techniques to map deforestation caused by illicit activity and pilots UAVs to survey and gain detailed insight into the drivers of deforestation. So very good, excellent, and thank you for being here and proposing this challenge, Lorenzo and Jorge. I leave you the floor now.
Thank you, Maria. I will start with that. I have a presentation. I'm going to share the screen. Hope everyone can listen clearly.
Yes, and, we do.
And see the screen that I'm sharing?
Yes, yeah, perfect.
Great. So I will start with the presentation, then maybe we'll leave the floor to Jorge at the very end for if he wants to make some remarks. So as you say, this is the challenge we propose is aims at detecting automatically illegal runways in the Peruvian Amazonian basin. I will describe a bit the phenomenon of the illegal runways that is linked mainly to trafficking of narcotics, but also other illegal activities like illegal mining. These are infrastructures that are usually very important in remote areas, and they, let's say, they pop up and then they are abandoned. So they first are active, cutting the forest, and then they are abandoned, and they move somewhere else because, of course, then law enforcement come into the picture to destroy or let's say to try to avoid this issue. So these runways represent a very big issues for both security, but also for environmental sustainability and environmental conservation. So from the security point of view, they, of course, they facilitate organized crime, they undermine the rule of laws, they contribute to the regional violence, instability, problems in the native communities, but also they are a big threat environmentally because they often are a trigger of deforestation and forest degradation, and they lead to further degradation and deforestation around them. And so this is really affecting the biodiversity and also the related activity, like such as, for instance, illegal mining. That is once you have an illegal mining site, then you know there are disposal of toxic substances. So it's not only affecting the forest, but also the environment in general, just for the disposal of mercury, for instance, in the wastewater. So now UNODC is currently carrying out a research on this, on the spatial distribution, the impact of these runways. We use, for the time being, visual interpretation of high resolution images, mainly NICFI, as you can see on the left, and sometimes very high resolution. Of course, what will be, as you see, for instance, just what we were saying before, no, that how can the environment around also change around these runways? So, in what is the aim? Our aim is to have an early warning, early detection of these airways, and in this is where AI come to the picture, not GeoAI, because what we need is a system, is a model capable to detect automatically on maybe open source satellite imagery, the way that everyone can be enabled to come to these findings, this detection, and take the government then can take correct measures to tackle this issue. So let's go in the details of the challenge. So it's developing, leveraging GeoAI techniques such as machine learning, deep learning, innovative methods for automated detection of clandestine runways, using open source medium resolution imagery, and both optical and radar. And then also compare the performance of several methods, so from machine learning or different type of deep learning, I don't know, convolutional neural network, long short-term memories, different approach, and see how this model, so the performance of the model increases or decreases, and also how can the radar be helpful, because in the Amazon basin, one of the big challenges is the cloud coverage. So this is why we strongly encourage to use radar. So study area is the Peruvian Amazon basin. In this case, we have the department of Ucayali that is highlighted because it's very dynamic in this sense, but with a lot of this type of activities going on in these years. But of course, there are also other areas prone to this phenomenon. Data sources. So data sources will be open source, free accessible satellite data. So what we really recommend in this case is the use of Sentinel-1 and Sentinel-2. Sentinel-1 because, as I said, the radar can really be helpful in the Amazon, in an area where cloud coverage is really typical and can be go across the year. And then also because other medium resolution images such as Landsat might not be able to detect some runways which have a width that is maybe even less, sometimes of 20 meters. So this will be really challenging. What you see going on is an animation of land use change made on Sentinel-1 data. And you can see on the right a runways that is shaping up. So we will provide a limited number, I think 180 sample in a shape file that will be line going along the length of the runway. And these are validated samples, so that would have been double-checked visually, and they are active runways. And to each one will be associated the year of detection, because as I was saying before, it's a very dynamic phenomenon in which the runways can be dig up and then abandoned and then activate again, etc. So there are additional training samples available, for instance, in some online tools. This you will find the link also in the challenge, the webpage of the challenge. But of course, those are not validated, so they can be additional training sample, but please double check with your eye on the satellite imagery. So UNODC will then provide some test area of interest. So there will be like square tiles where the participant will have to find, to search and hopefully find for clandestine runways. And for each of these AOIs, we will give a specific year where the participant will have to search the image for it. What we expect as deliverables will be spatial dataset containing the clandestine runways identified, the data source used to train the model, and the script, so that the results would be replicable. So, and then of course a final report detailing methods and results, and also maybe the comparison among different methods, etc. That will be a plus. Timeline, unfortunately, we were not so diligent as our colleagues, so our data set is not yet available in the platform, but will be soon. And but the deadline for submission will be in line with the other colleagues, 11 November 2024. here you see the link to the Zindi platform where our challenge is already advertised, but for the enrollment we will need to wait few more days. And so that's it. There will be a prize, of course, that will be shared with, we will be 2,000 Swiss francs shared with ITU, between ITU and the UNODC. And I would like also maybe to hand over to my colleague Jorge, who took care of collecting the data, validating the data, working in Peru. He has a lot of experience on this type of issue. So please, Jorge.
Thank you, Lorenzo. I just want to wish all the best to the participants whose value, knowledge, and skills will be essential in confronting and mitigating the threats posed by organized crime to this vital region. Thank you all.
So thank you.
Okay,
thank
back
you.
to you, Maria. We are done.
Yeah, thank you. Thank you also for this exciting challenge. And I'm looking forward to seeing the results in the end, because also this one is very tricky and really important in my opinion. So it's a good exercise that you young people can do, and meanwhile you are also helping UN for these very important topics. And now I want to call all the presenters here, because we have some questions from the floor. And specifically, there is a first question for Peng Shu. People are asking if the spatial resolution you are proposing, is it sufficient to detect this plastic cover?
Yeah.
So have you already tried it?
Yes, I can respond to this question, as we have providing the Sentinel-1 and Sentinel-2 data set to identify the agricultural plastic covers. And for myself, I have done the work several years ago using Sentinel-2 data set with 10-meter spatial resolution to identify the plastic merged fields. And I have also do some reviews using satellite images for this topic. Because now the Sentinel-1, Sentinel-2 images are of very good spatial resolution, which are enough to identify the crops. So I can say that the dataset we have provided is sufficient to identify the target we are proposing. That's it.
Okay, thank you. So in any case, you don't want, or we don't want people to use proprietary images that cannot use by other people. We want to provide an enough general solution in such a way, as we already said, that is replicable, because obviously if you buy some very high resolution imagery, this can be easier, but in many cases is not affordable. So in order to make everything affordable, we want to consider data which are open, or that can be available without without buying them, correct?
Yes.
Good. And so let us see what we can get using the open available data. Okay, thank you, Peng Shu, for your answer. And let's go to Francesco. There is a question for you. There is one person asking why you are not considering wind speed and direction in the, as one of the variable that you want to include?
Yeah, yeah. Is as I mentioned, there is the freedom. We give some variables, but we leave freedom, and of course, wind is definitely something that I would take into consideration. So it's on the floor now, so that's actually a good hint to participants to also use wind. Of course, that is actually a matter. You have to find the correct sources, and also that's also a challenge because there is some information about wind, but it's at the different scales and different areas. But you can also use, of course, you can decide that you want to use maybe more regional information. It's up to you. But yes, definitely wind is part of it.
Okay, so in this case, anyway, if somebody wants to add also wind, it means that in the solution they will provide also the wind data they used in such a way that the people checking can reuse them
Yes,
if they
absolutely.
decide to do that. Okay, super good. And then I hope that the person who asked is fine with these two answers. The person was always the same, Gies van den Dol. I hope that the name was correct. Sorry, but my pronunciation probably off. Probably the Netherlands is not so good. Anyway, he has also a third question for the third presentation. And the question is, how can we distinguish between runways and illegal lodging roads, even though their shape and forms are very similar? This is for Lorenzo and Jorge.
So thank you for the question. I think Jorge will be in a better position than me, is more expert than myself, but I can also attempt. There are some characteristics, some features that are specific of the runways, like the length that is always within a certain range that, if I remember correctly, about between 700 minimum and 1200 meters, and also the width, and also some other surrounding features, not how it's located and etc. But it's true that sometimes, I have to say, I have heard also that traffickers they land in roads. They can even land in some dusty roads if straight enough. So it will be very challenging, I have to say. And I hope, Jorge, you have. I'm sure that you have something to adapt to this.
Yeah, basically the lane is the mean lane is, as you said, is 700 meters, and also you can see the phenology of the vegetation within this illegal runways. When you see roads, for instance, they will be roads for many years, but for illegal runways, they use for 1-2 years, and then the police destroys those runways, and then the vegetation again takes place in this area. So that's another way.
Yeah, and maybe if I can add, sorry, is also to take into account the temporal component. So the time series analysis is very important. That's why it's very important to leverage on open source satellites such as Sentinel.
Okay, thank you. Thank you for your answer. So this is very important. So 700 meters, we have to keep in mind this number, more or less. And yeah, and then we know that is challenging, because if not, you would propose a challenge about that. If it was, so easy. Okay, so I hope that also this question is answered. The last one is more general, it's for all of you, and it's a question from, again, a difficult name, Ramatsimela Lebogang Falele. and he or she, sorry, I don't know the gender, has this question. So they have this question on data collection. So how and where did you collect your data? And did you come across any challenges on the process? So if you can explain for your challenge where you find your data and if you had problems in finding the data, starting from Peng Zhu.
So from my side, for the agricultural plastic cover, we selected the latest year, which is the year 2023, because in the latest year there are the most availability of the cloud clear sky satellite images. In addition, the training samples are collected by visually interpret. So because it is easy to interpret the plastic covers from the very high resolution images from Google Earth, Google Earth, and also from the Google Earth Engine image time series. So we use the visually interpret methodology to collect the training samples. So in this case, we are now providing the training samples, the best availability of the cloud-free satellite images. So this is the reason why we select this time period and how we collect both the satellite and the ground truth data set. Back to you, Malia.
Thank you, thank you, thank you, Peng Shu. And what about you, Francesco?
Data, well, I think I'm on the same line as Feng Shu. I don't have much to add.
If I can add something, Francesco, the point is more with respect to local data, because if you refer to satellite data or Copernicus data, they are generally documented in English. If you refer to local data, they are open, but in many cases, as they are collected by local environmental agencies, in many cases, the description is in Italian, so it's not for this specific case, because we refer to Italy, is in Italian, and so it could be that it's not easy for the people to find the data, even if they are available and they are open. So this is a problem which is general. Every time you have to deal with the local data, unfortunately, very often they are provided in the national local language, and so it's difficult for other people outside the country to understand. But now we have a good translator, so we can use translators for understanding. And what about you, Lorenzo and Jorge?
I think this is more for Jorge, since he actually collected all the data.
Yeah, thanks. We used freely available satellite data from Planet, the monthly mosaic. You can also use Sentinel data, Sentinel-1 radar, and Sentinel-2, the optical satellite images, to detect these illegal runways in the Peruvian Amazon.
Okay, thank you. Thank you. So I see that there are no other questions. I want just to recap saying that also this year we have these three interesting challenges by now, because be prepared that at least two challenges are coming in the next period. So again, one challenge proposed by FAO with respect to the plastic cover, and Peng Qiu is the person of reference with respect to this challenge. One challenge proposed by two universities, the University of Padua and the Politecnico di Milano, and Francesco is the person responsible with respect to this challenge, and it is related to NO2 pollution The last challenge referring to illicit runways in the Peru Amazon. And this challenge is proposed by Lorenzo and Jorge. With respect to the data, you have to refer to Jorge. With respect to the general problem, you can refer to Lorenzo, correct? Jorge and Lorenzo? Okay, so unfortunately, we are a bit late, and so I don't think that there is time for other questions. You can contact directly the responsible that now you have known. And then I want to thank all of you. This is just the beginning. Some challenges have already started, like, for instance, the NO2 challenge has started already, and there are 113 active people working on that, and 281 people enrolled. So at least now it seems to be a success, and then I believe that it will be the same also for the other challenges. So thank you so much. And Andrea, are you here also? Okay, thank you. Thank you to Andrea, who is always so kind of organizing these events and helping in the challenge. And thank you also to Julian, who is organizing this webinar and helping us from the technological point of view. Thank you to everyone, and good luck to all of you who want to compete for this challenge. Andrea, do you want to say something?
Yeah, thank you very much, Maria. I wanted to thank from IT side also our hosts and speaker. Thank you, Francesco, Lorenzo, Jorge, for this great webinar. I think it was really informative and a very clear introduction to those three really interesting problem statements, which are all very, very relevant for the SDG. And I'm sure that we will have many data scientists which will be competing to provide the best solution. I was very much impressed as Maria, you were saying that we have already this air pollution competition online since a couple of weeks. I was so much impressed by the numbers, already 113 competitors who really submitted the solutions. I also wanted to say that the presentations will be available in the neural network, so you can download them. And of course, you can rewatch the recording on YouTube and the neural network. Thank you very much, Maria, for having moderated this event, and to our engaged audience for active participation. So stay tuned for those exciting developments on GeoAI. And thank you all again for your participation also from my side. And let us give back the floor to Anna. Thank you very much.
Ciao, ciao, ciao.
Ciao.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the eShop, and build your personalized AI for Good program. Let's shape the future of AI for Good.